Hey, so I'm Carlos, and I was asked to prepare some notes about pandas. And I figured it would be maybe a good idea if I recorded myself going through the notes in case that helps anyone understand this a little more clearly. So the library I'm going to talk about today is called Pandas. And just to spice things up, I'm going to throw in a bit of Seaborn, and you'll see why that is. But basically, these two libraries are kind of ubiquitous nowadays if you're dealing with any kind of data in Python. Really at its core, the problem Pandas is trying to solve is the problem of handling tabular, or sometimes called matrix data, programmatically. So in Python, so you can write your code to do things with tabular data. And this is something that's been useful for a very long time in many fields, including the life sciences. And the most widely used software for dealing with this kind of data to date is Microsoft Excel. And I'm sure you're all familiar with the Excel table with rows and columns, and you essentially store a value inside each of these columns, and you can put, you can assign names to the columns, organize, even do plots. So Excel is a very powerful tool, and it's very relevant in many domains. But today I'm going to explain a Python module for doing kind of everything Excel can do. And I'll give you what I believe four decent reasons for why it's worth having a look at this. First, it's free. So Seaborn and Python are open source libraries. They're completely free to use. You're free to contribute to these libraries. So if you have any ideas for any features that haven't been implemented, you can add them in yourself. So this means that there's a very large community of people working on this tool and contributing every day to it, which means it only gets better really fast compared to some other tools like Microsoft Excel, or even more sort of programmatic tools like Mathematica and things like that, which are proprietary. So that's often they can be very powerful, but progress of features can be very slow, and also you have to pay for them. Another reason is that using a Python library for tabular data makes automation and complex manipulations a lot easier. So you can include any kind of logic or any kind of changes you want to your data. Everything you've basically learned up till now in terms of how to handle a program's execution, you can apply to tables, and this can be very powerful if you combine it nicely with Python. And this kind of goes, the third point kind of follows, meaning if you're directly dealing in Python with this kind of data, it's integrated with the rest of whatever Python or programmatic tools you're using. So if you're managing a database, a web server, if you have some machine learning models that use data, you can sort of prepare the data, handle it, as well as make predictions with it or visualize it all in the same Python ecosystem. So this kind of makes your whole work setup very seamless. And one of my personal main reasons is that clicking buttons hurt. So I don't like clicking on the mouse. And since all of this can be done by typing, I'm happy about that. I just realized that I have a lot of emojis. I got very carried away using this new markdown editor for text. So forgive me if I use too many emojis. I'm excited about them. Okay, so in this little tutorial, I want you to come out with four basic components. One is how are we going to actually load data into Pandas, so that we can use it in our programs. Then quickly look at ways to inspect it, so see what kind of structure the data has, get information about specific entries. Then we're going to go into some basic manipulations. So what if we want to change the data or make some computations on it? How can we do that? And we're going to end with a bit of visualization. So once you're happy with the format of your data and you want to essentially show some result or some analysis on it, we're going to do that with visualization. And Pandas has built-in plotting functionalities, but I'm going to use I'm going to show you a little bit of how to use a different library called Seaborn, which is very powerful for visualization, and especially because it integrates directly with Pandas. So if you have data in a Pandas format, you can plot it very seamlessly on Seaborn, and you have many, many different types of visualizations you can make sort of pre-built and with very nice aesthetics. So I should say that these libraries are extremely extensive. So there's tons and tons of functionality that I will not even come close to covering in its entirety. And so the purpose of this little session is not to cover everything that Pandas does, but to give you a little taste of what kinds of things it does, what kind of logic goes on behind it, and to get you used to looking at the documentation. For whatever kind of needs you may have, it's very likely that there's already a feature to do it, and you need to go up and online and look it up and see how it works, and then implement it in your own code. So I should say, for example, whenever I use these libraries, for every time I sit down and try to do something on them, I probably do like, I don't know, a few dozen Google searches. Part of that is because I'm not really an expert at these. I just kind of use them when I need to. So it's not, I haven't memorized all the functionality, and another part is just because there's so much to know that it's really impossible to have it all off the top of your head. So it's not really weird if you're always Googling stuff. It's completely normal, and that's kind of the point of having these libraries, is that everything is organized in a way that's easy to look up, and you don't have to memorize anything. Okay, so we're going to play with the real data set, and to get one, I'm using this website called Kaggle, which is essentially a website where there are contests. Oh, I put the wrong link in. I'll fix that. Anyway, we can go to Kaggle. It's essentially a website where people and institutions can post data sets, and they say, okay, here's a data set, and we're trying to predict some, or achieve some kind of model that predicts something about this data. Like maybe there's some real estate data, and you want a model that's really good at predicting the price of a house. So someone can open up a competition and say, I want anyone to try out this data and see if they can beat, whoever else wants to try at predicting something about the data. So it's kind of like a contest, who can get the strongest model for a given data set. But for now, we're just going to use it as a source of tabular data. So that's Kaggle. You can browse it. It's very cool. Anybody can enter in one of these competitions, and sometimes they give out money for the best models. Money, and I imagine also jobs. Okay, since COVID is the hot topic of the world and of this course, I looked for a data set related to COVID, and I found this one. I hope the link works. Yes. So it's essentially a data set which collects the number of cases, either cases and deaths for a set of American states and their counties, so which I imagine are subdivisions of states, and a date associated. So I think it's a daily count, essentially. So it's kind of these charts we've all been looking at very closely. The data is there. So we need to acquire this data somehow. There's a simple download button here. You need to sign up to do this, to be able to download, I believe, but it's a very simple process. You just sign up, you click save, and you're going to get back what's called a CSV file. So let me open it up. So let's see, what was it called? US counties. I'm going to move it from my desktop to my temp file. Okay, so I'm working in my temp directory, and I just want to see what's in this file. So I'm going to go uscounties.csv. Okay, so it's essentially a normal text file with the top line being the column headers. So date, county, state, FIPS. I looked it up. It's some kind of identifier for a county, so we're not going to really worry about it too much. Number of cases and number of deaths. Okay, very simple data set. Has 176,000 lines. Lots of data. Okay, so that's what we're going to be working with. And this is essentially a text a human readable version of what Excel would use as an Excel format file, which kind of turns this type of data into complicated, well, not complicated, but into a binary representation, which only Excel programs or programs that are specialized to do that can read. So typically for dealing with Python or any kind of programmatic use of the data, we prefer a plain text file. So CSV is one of them. It stands for comma separated values. So it's essentially a value separated by a comma, right? And if we separate this line by commas, we get a column entry for each row. And that's not to say that you can't work with Excel data on Python. And we'll get into that right now. Okay, so now I have the file, but what if I'm writing a Python script? So I'm going to call my script covid.py. And what if I want this, use this as essentially a Python object? So very simply, I load it. Pandas has a functionality for that. But before I do that, I need to import Pandas. So I say import Pandas. I'm going to give it a nickname, PD, just by convention. And I'm going to say df. It's going to be the name of my Pandas object. Use the Pandas library dot and its method called read CSV. And I give the path to that CSV. So I think it was usstates.csv. Okay, so that's the path to my file. I hope I used the right name. Let me run it. And no, I didn't use the right name. US temp. US counties, sorry. Okay. Okay, so that should work. I've given it the file name. Okay, so no errors, then I can load it. If I had a Excel file instead, I would simply use the read Excel function, and instead the file would be like .xls or something like that. Okay, and at the end of the day, you get the same thing. You get what we're going to call a data frame object. Okay, so what are data frames? Data frames are the core object that Pandas uses, and it's essentially its name for an Excel table. So that's just the choice of words. And we're going to use, so we loaded the CSV file into a data frame. If we were to print the type of this object, we should get something that says data frame. So there we go. So it's a type data frame object. So that means that it's the data itself and also a bunch of functionality around it. So this object carries a bunch of methods that are going to help us do a lot of things with the data. The first thing I usually do when I load a data frame is I print what's inside of it. We already did it with a text editor, but I'm going to just do it from Python. So I can print my data frame.head. So head is a method that belongs to the data frame class. And it's going to give me just print the first 5 rows, so I don't like overload my screen. And I can have a look here. This looks exactly like an Excel table, or when we looked at it, looked at the text file itself. We have our columns, we have our rows. Okay, very simple. We can also do a tail, I believe, to get the end of the data frame, in case you want that. Okay. So like we saw, each row is a day, and it has a few columns describing what happened on that day in that country, in that county, and that state. Okay. All right. So the main way to understand this data is as columns and rows, and essentially Pandas gives us access to that information directly. So I can also print df.columns. So columns is an attribute of the data frame object. And if I do that, I get a list of columns that belong to this data frame. Okay, really nice. Another way to kind of understand what's going on in the data. Now, if I were to say, okay, well, now I know what columns are out there, let me just print the data inside a single column. So print df at, let's say, the date, right? And that should give me only one column, and that's the date. There we go. So these are all the date values that we have. So I can select columns just like I would in Excel. I can also select multiple columns. So if I wanted the date and the county, for example, I would just pass it a list, a list of column names. Right, so there's my list of column names. I index my data frame with it, and that should give me back 2 columns. There we go. Okay, so now we have the date and the county columns. Cool. And we can do a similar thing with rows. So let's say we wanted the second row of this, or the third row of this data frame. I can say, just print it, data frame or df.iloc, so I location, and I can just pass an index. So index 2 should give me a row. There's the row. It prints it in like a nice sort of user-friendly format. So you have along the vertical here, the different column values for this particular row. And I believe you can also do slicing. So from row 2 to 5, there we go. I've got 3 rows for the numbers, for the indices between 2 and 5. Cool. All right. Very simple, very convenient. And then, okay, so once we have selected a set of rows, we can also then select a column within those rows only. So if we wanted the date for these rows between 2 and 5, we just add in an indexing using the column that we want to use. So in this case, we would get the date for the columns between 2 and 5. Okay. So this is kind of the most basic form of selecting data in the data frame, and this gets very, very powerful very fast. So there's a lot you can do with selecting data, and that's kind of where Pandas really shines. And I'm just going to give one small example of doing something a little more advanced, and then throughout the rest of the tutorial, I'll use slight variations of this to show a little bit more of the functionality. So again, let's go back to my print, and I'm just going to print my df. I'm going to use this .lock attribute. So before we were using iloc to select column rows, and lock looks at columns. Okay. And I pass in square brackets, essentially a condition or a selection that I want to make column-wise. So inside these square brackets, I'm going to put a condition. And I can use basically standard Python logic to do this. So I can say, you know, what if I wanted to print the columns where deaths, print all the rows whose column value for deaths exceeds the column value of cases times 2. So to do that, I would say, I would pass to the lock attribute the column that I want to use, so deaths. So it's going to look at all the rows in column deaths and then compare them using a greater than operator to the ones in cases. And then just for fun, I'm going to multiply that by 2. So I can apply essentially operations to entire columns. So this is going to take all the rows in the column cases, multiply it by 2, and then compare it to all the rows in the column deaths. And then for all the rows where this condition is true, the lock method is going to return them to me. So this should essentially be sort of selecting rows based on these conditions on the columns. And if I print that, I should get, okay, there I got a bunch. In the document, I only printed the first few. But they should have given us all the rows where the deaths exceeds the number of cases times 2. So I think it looked like it worked. Deaths here is 608, and multiplying this by 2 is certainly greater than that, less than that. So these would be the valid columns, rows. So this is kind of like a way to introduce more complicated logic into your selections and starting to filter data and get a better understanding of what's going on. And you should check out the links on the document for more information on what you can do with this, because this is really, really just a tiny, tiny tasting. All right. Another thing we can do is modify our data frames. So we can essentially compute new information and add it in, say, as a new column. And this is also very straightforward to do. Like, for example, let's say we wanted to detect all the counties where there's a large number of cases. And we wanted to have that be a new column in our data frame so that anybody looking at it can just kind of look at this column and determine whether or not they should, for example, really pay attention to this county because there's a lot of cases, okay? So this would essentially boil down to creating a new column in the data frame. And the way you do that is really simple. You say data frame at whatever new column name you want. I'm going to call it hot for hot counties, the ones that have a lot of cases. And then I'm just going to select the cases, the rows where the cases are greater than some value. So at cases is greater than 100. Okay, so this is going to return this, the right hand side is going to return all the rows where the cases exceed 100. And it's going to assign that that value to the hot column, a new column in our data frame. Okay. So now if I print the data frame at its head, so the first few rows, I should see something new there. And I do indeed. So these were the original columns, and I've added in this one, hot, where it's a true or false column that tells me if the number of cases is above 100, they should have been true. Let me just print the whole thing. Maybe we'll see some ones where it is true. And so that's essentially a very simple way to add in new data. So there it is, true for this county with 182 cases, Winnebago. All right, cool. So very simple. I should say that this is different from the lock method that we saw earlier, because this is evaluating something on each row. It's not selecting them. It's actually for each row giving us a value. So df at cases greater than 100 is still going to have the same number of rows as our original data frame. It's just that there's going to be a value associated with it. So it's kind of what we included in the lock earlier. So this, like, for example, df at deaths is going to be the same number of rows as our original data frame, right? This whole thing. And then what the lock does is it filters them. So you compute something on your columns and your rows, and then you pass that to the lock. And for any value that evaluates to true, that's kind of what it filters in to the selection. And that's why when you print, you can have very few rows because maybe some of them didn't pass the condition. So it's not the same thing to say just df at cases versus using the lock selector. Okay. All right, so let's say we're happy with this data frame with this new column, super useful, and we wanted to save it, store it, so we can maybe publish it to Kaggle or send it to a friend so that they can process the data. Very simple, we just do df.toCSV. We pass our data frame object and a name that we're gonna give that new file, so new data.csv. I forgot in the documentation, oh no, sorry, we don't need to pass it because it's already passed by the dot operator. So df.toCSV takes our data frame and uses its method toCSV to save it to a file on disk, okay? And if you wanted to save it for some reason as an Excel file, you can do that too, df.toExcel. And there you go, very easy. So you can work on your data frame. Once you're happy with it, store it, and then go back to it later if you've added anything or changed anything. All right, getting a little more advanced here, we're going to talk about grouping. Again, this is another thing that is a little involved, and really understanding what's going on in the background might take a bit of reading. But the reason for using this is pretty natural. And I think an example is going to illustrate it. And I think you should be able to get a good idea of at least how to start using this because it's very useful. Okay, so let's say we wanted to get some averages over some agglomeration of our data. So we saw the original data had one row per county, right? And each county belongs to a specific state, right? And let's say, we wanted to know something about the state level of cases and not necessarily things by county, right? So this is an operation called grouping, where you essentially squish rows into a single row according to some column or some set of columns. So if we wanted to say, for example, take the average number of cases per state, then the GroupBy function would be something we want to use. and it's quite straightforward to get going. So let's say we wanted to group our whole data frame by a column state, meaning all the rows with the same column value would be grouped into one row. All right, so that would be using this, the GroupBy. So let's say state, and this returns a new object. So your original data frame stays intact. So that's why I'm using the equal operator here, GroupBy. And I choose to group things by state. Right, so this gives me an object called a GroupBy object, and on its own, there's a few things you can do with it. You can iterate over groups and things like that. But for now, I'm just going to show you what happens if we actually want to collapse these rows with the same column value and take some aggregated statistics on it. So let's say we wanted to take the mean. Right, so what this would give us is a new data frame where all the rows with the same value for state now are aggregated into one row, and when you aggregate them, you take the average or the mean of all the values that fell into that group. So when I print this, I'll have a new data frame with essentially one row per state, and the number of cases now is averaged by all the rows that had that state value. Right, so Alabama on average has 95 cases, 3 deaths. Okay, and you see the hot attribute, which was true or false, now became kind of, I guess you could say, a probability. If you think of a true as 1 and a false as 0, then you can take an average and you get something that probably doesn't make a lot of sense. But anyway, Pandas still does it. Okay, you'll notice here an NaN. So this means probably that there were 0 cases somewhere, and Python wasn't able to do a division, and it got a non-valid number. But so there you go. This is a new data frame where we have per state some average numbers. Okay. And I should say, you'll notice that the state label is kind of lower than the rest of them after the grouping operation, and that's because there's this notion of an index in Pandas. In the original data frame, this index was like 0, 1, 2, 3, 4, 5. But when it does the grouping, it uses the column that you use to group as an index over the rows. So this is something that you might want, something that you might not want. And for now, we don't want it. So we can just pass an option to the GroupBy method, which is as index equals false. And then this way, it uses as index basically numbers. So if you want to access rows, we still use numbers. And then state stays as a column. So in case we want to use it as a column value to filter or whatever, it's still there. So this can be practical. All right, and then yeah, so using the .mean function collapses out all the rows and then takes their average and gives you back a new data frame. All right, again, I suggest reading the documentation here. There's a lot you can do with this. Okay, something simple now. And I think this will be the last sort of pure data Pandas thing I'll demonstrate is sorting. So okay, we got the average number of deaths or the average number of various features by state. And what if we wanted to quickly see which ones are the worst ones off? You know, so first I should say we can, once we've done the grouping, we can print for a specific column. So say grouped at deaths. So if we want to just look at the deaths by state and not have all this other stuff, I can just look at it and okay, there I get a column and I have a bunch of values which represent deaths. If I want to know which state is the worst off, this is kind of hard to see. So what I want is to do a simple sorting. So I'm just going to do a sort. So I can take my data frame, state grouped, right? And then I use this method called sort values. Oops, sort values, and I give it a keyword argument, which is one or multiple columns that are going to be used in the sorting. And in this case, I just want to sort using one column value, and that's deaths. So I want my rows to be ordered by number of deaths. And as an option, I can tell it to order in increasing or decreasing order. So I want in decreasing order. So I want the most deaths at the top. So I'm going to click, I'm going to put ascending, not click, equals false. Okay. And that should sort my entire data frame according to the deaths value. there it is. I should see at the top the most deaths, right? Not FIPS there, deaths here, 274. Okay. And just to make things easier to see, I'm just going to pick 2 rows to show. So state and deaths and deaths. Okay. And there we go. We have a nice here, top most deaths is New York. And this was originally the 33rd row, but now it's at the top. And we can go all the way down. Okay. All right. So at this point, we're ready to maybe do some visualization. Like I said, Pandas has some built-in plotting functionality, which is a little bit somewhat limited, but it works. Like you can say you can take a data frame and do a dot plot, and it'll plot the data it has in some way. But most of the time, it's more flexible to use this other library called Seaborn. And Seaborn is a wrapper. So I'll show you their website. By wrapper, I mean it's a set of functions that essentially call functions from another library, which tends to be a lower level library. So in this case, it's a wrapper for matplotlib, which we've already seen. And it kind of groups functionality in matplotlib and takes care of smaller details and lets the user deal with things at a higher level. So it worries about smaller things that you might be annoyed to code each time. So that's what we mean by a wrapper. But essentially, you would be able to do everything that Seaborn does using matplotlib. It's just that matplotlib kind of puts a nice what we call an API on top of it. Okay. So here's the Seaborn website, and these are some examples of the types of plots you can make. So they're very beautiful. They also have like a nice kind of built-in styling. But there's a ton of different plots you can make, and usually they involve like 1 or 2 lines. Whereas if you were to do this on matplotlib, it would be dozens of lines because they've already done the matplotlibing for you. And they've defined a few different types of plots. So this is what they call a cluster map. And you essentially pass your data frame a few options and it does all the matplotlibing for you. Okay. So we're going to do 2 simple plots from our data using Seaborn. And like I said, the main thing that's attractive about this is that it works directly with Seaborn data frames. It also works with standard arrays or NumPy matrices. But if you have a data frame, then you can very conveniently plot its different features on Seaborn. So what if we wanted to plot the number of deaths per day? So if we were to look back at the original data, we see that each row is actually a day for which deaths were recorded. So we can plot kind of a progression of the infections against a time axis. All right, so I think we're back to our original data frame here. So I want for each day the number of deaths that occurred in a specific state. All right, so Seaborn has some nice functionalities for this. I'm going to import it using import Seaborn as SNS, again by convention. I'm also going to import matplotlib as PLT. Okay, so usually you import these together because there's still some matplotlib functionalities that you need to work with once you've drawn your plot with Seaborn. We're plotting X, Y time-wise. Usually this is a line plot. So Seaborn has a method called line plot, sns.lineplot, and I can directly tell it what's my data. So I'm going to use my data frame. And I'm only going to be interested in, if I plot every state's progression by deaths, I'm going to have 50 lines on top of each other. It's going to be really messy. So I only want to look at 3 states. All right. And we already saw how to select rows with specific values. This is with the .lock option. So I'm going to pass .lock a condition. I'm going to accept rows only if their state column value is in. So this is a nice functionality. You can check is in, and I'm going to pick 3 states. So I'm going to pick New York. Oops. I believe New Jersey. And let's say California. Okay. Let me break the line here to make it easier to read. Okay, so that's my data. It's my data frame where I've filtered out the rows that have the state value in one of these three possible options, right? So the next thing I want to pass it is what's going to be my x-axis. So it's going to be the date, and my y is going to be the deaths, all right? And the hue, what we pass is each line is going to have a different color, and that color is going to depend on what state we're looking at. And then this is where I need the matplotlib, plt.show. If I did that correctly, I should get a nice plot. Gonna take a bit of time. Okay. Come on, come on. There we go. All right, there it is. So we didn't have to worry about setting legends automatically, colors, shading, nothing. Matplotlib, Seaborn directly using our data frame was able to format everything nicely, and we have a nice progression over time of the number of deaths. I mean, it's not nice, but the visualization is nice. You'll notice here there's a bunched up axis labels. That's just because we have many days and it's plotting them on top of each other. I added a little hack here that you can use to space out the ticks. And so you can paste it in here. And so basically line plot returns what we call an axis object. So we're going to save it as G, and then we can do stuff on it. So once it's done the drawing, it gives us back the object, and we can tweak it afterwards. And the tweaks we're doing are more low level, as it were. So we can use matplotlib functionality now to set which ticks are visible and which ones aren't, depending on some count. So here we're every 30th label, we're going to make sure that it's visible, and every other one is going to be not visible. So now we should have fewer tick labels, and our plot should be easier to read. There it is. Okay, so now much easier. And the hue is by state, X is date, and Y is deaths. All right. Okay, so that was a nice little seamless introduction of Seaborn and matplotlib. And let's do one last one, all right? And end it off there. So I'm gonna just comment this out. This too. All right. So what if we wanted to ask, what's the mortality rate in the different states? And this is gonna practice a little bit of logic on top of the data frame as well as some simple plotting. So I thought it was a nice example. So what we want again is to group our data frame by state. So we're working again with our original US counties CSV. So I'm going to define a new data frame. I'm going to call it tot for totals. I'm going to do a group by operation on it. And I'm going to say group by the state column. So anyone with the same state goes to the same row. I'm going to set as index equals false again, just to keep the column titles. And this time I'm going to take a sum over all the rows with the same column, with the same state. So I want to basically get totals now. So what's the total number of deaths, or the total number of any column in this data set by county? And then I can use this to create a new column, and I'm going to call the mortality rate. So I can say the total is going to have a new column called mortality. And that's just going to be taking the deaths column and dividing it by the number of cases. So again, so this is a very crude bit of stats. This is not meant to be at all taken seriously, but we can define a column that computes the quotient between two other columns and store that in our data frame. Now we can basically, again, prepare our data frame so that it's easy to visualize. So we can say sort it. So df.sort values by equals mortality, and ascending equals false. So again, we're going to order our rows, and whichever one has the highest mortality is going to be at the top. Oops, I should call this total, not df, right? So this is our new data frame totals, and we're going to sort the rows by mortality, and we want the highest mortality at the top. And then Seaborn offers another type of plot called the bar plot. So sns.barplot, where now I'm going to plot x equals state, y equals mortality, and data equals totals. I should fix the notes here. They're missing that call. And we're just going to do a plt.show. All right, there we go. So as you can see, the rows are sorted. So we have a nice downward trend. The states are all jumbled up. So that's not super nice. Maybe if we rotate it, we'll have a better view. So maybe I'll switch the y to be the state and the x to be the mortality. And I'm going to tell Seaborn to plot it in horizontal orientation. So orient equals h. And this is something I Googled. So I went Seaborn. Well, it's here, I guess. Like I should go to the API. I should search bar plot. So where's bar plot? Bar plot. And I see that there's an option, XY data, we did it. Order, not necessary. I guess we could have used Seaborn directly to sort the rows, but I want to see if I can orient it differently. So the orientation of the plot, I want it to be horizontal now instead of vertical, which is the default. So I have to give it an H. So I say orient equals H. All right, so that should flip my plot. And if I plot it now, it should look a lot nicer. There we go. So that's a lot easier to read. Gives a nice default rainbow coloring. And there you go. So that's all I have prepared. I hope that was fun and instructional. And thanks for listening. All right.